All right, so this is the video for 21.11, 21.11. So this section's about graphing polar coordinates, and the two videos that are on the My Math Lab do a pretty good job of showing you how to graph these by hand. So I'm going to focus on just two really special cases that are really simple, and then I'm going to show you how to do it in the graphing calculator. Okay, so the first case that I want to talk about is graphing something that just has theta in it. So what if you just have theta equals pi over 4, for instance? What would that create in polar coordinates? This means that the r value is free to be anything. So if we think about it, if r could be anything, but theta always has to be pi over 4, what are you going to end up getting? Well, let's plot some points and think about it, right? If r were 1, we would count out, here pi over 4 is right in the middle of the first quadrant, so we would count out 1 unit towards pi over 4. If r were 2, we would count out 2, right? If r were 3, we would count out 3. And r could be decimal values, so actually, can you see why we're going to get half of a line there? Now, what if r were negative? Remember I said r could be whatever. So what if r were negative? Remember, negative r values send you in the opposite direction of the angle. So if r were negative 1, we would count out this way 1. R were negative 2, if r were negative 3, and so on. So look, we get a line. Okay, so if you just have theta equals, you get a line. Now what if you just have r equals? So let's say r equals, I don't know, 2. What's going to happen? Well, r is the distance away from the origin, which we actually call the pole, right, in polar coordinates. So if r were to be 2, right, and theta is free to be whatever, just think about it. If theta were 0, that's here, we would count out 1, 2. If theta were pi over 4, we'd count out 1, 2. If theta were pi over 2, we'd count out 2 in that direction. If we keep this going, can you see why, down here, same thing, we're going to end up with a circle. So if it's just r equals, you're always going to get a circle centered at the origin. Okay? Alrighty, now let's look at some more interesting curves, and we're going to plot them on the calculator. I kind of showed you in the last video, right, that to do this, you want to go to mode, and make sure your mode is on polar. So make sure polar is selected. If you go to y equals, type in whatever it is you want to graph. I'm going to do some problems out of the book. Let's graph, this is example 3 in the book. You know what, actually, I'm going to do example 4. All right, what I'm going to do is I'm going to graph 2 cosine of 2 theta. Hit graph, and you see it. Now maybe your calculator's not working very well. One thing that is nice with polar coordinates is you can hit zoom and then go to fit. So you're going to zoom fit, and it will zoom in nicely on it so you can really see what it looks like. And these graphs look really interesting, right? So they call this one a rose. There's one that looks like a heart that they call a cardioid. I think this one is in your examples online on your website or on your My Math Lab videos, but I'm going to put this in anyway. So I'm going to graph 1 plus cosine theta, and I'm going to hit zoom fit again. Enter, and there it is. Okay. So that's pretty easy. If your calculator is not cooperating with you, I'm trying to think of some tips I could give you. I think zoom fit should probably fix it. In your window, you always want to make sure that your theta step is pretty small. Also make sure you're in radian mode for this, but make sure your theta step is small, like 0.1. Right now my x min is set at 0, or sorry, my theta min is set at 0 and my theta max is set at 2 pi. That should be good for most of these. But yeah, so go ahead and play around with this.